Morning. Am I audible?
Yes, sir.
Yes, sir.
Yes, yes.
Okay. So in this lecture, we will see this topic, failure modes effect analysis. So umpteen number of examples are available in the internet. So just you can go through them. So this one typical example, bank ATM example, we will discuss in today's class. So this is very much similar to the cause and effect diagram, but a little bit an improvement of cause and effect diagram. In cause and effect diagram, what we will take one effect, for example, core welded joint. So that is the effects, and then we will try to draw the fishbone diagram or the cause and effect diagram. There, first we try to identify what are the major causes, like whether the people is responsible, that is, men is responsible, or machine is responsible, or method is responsible, or measurement is responsible. So like that, environment. So many ways we are. Then we try to go for sub causes. So that's why it is called fishbone diagram. So the diagram is similar to, so that then we can make some recommendation how to. Any effect means many times we must understand the management point of view. Whenever effect may, we take the negative effect, but of course not. The rule is we can take a good effect also, and we can analyze also. But many times management effect means that is a bad effect, and then that bad effect, what are the causes, and then we will try to do that. So here, this failure mode analysis is also very much similar to the cause and effect diagram. Here also we are going to take one effects. We are going to, so the ATM example you will understand. And here we are trying to do something mathematically. Mathematically in the sense, not going to do calculation. So we are going to calculate one thing called RPN, risk priority number. Risk priority number we are going to so based on the risk priority number, we are going to do the analysis, which because we here in this FMEA, we will take many effects. It's not like cause and effect. And cause and effect, we have only one effect. Here we take many effects and we find out the RPN number, that is the risk priority number for the thing. And same way like Pareto analysis, whichever RPN is more, that has to be handled. That is good. So that how do you find out that risk priority number only? Risk priority number, that is going to be very important. So this learning objective, that is, we are going to understand the user. So one example we will see, and to learn the steps. So how do you, that basically finally you will learn how to find out the risk priority number. Mathematically, it's very simple. And allow us to, so benefits. So we will, that's why we are going for FMEAs. We will take so many bad effects. And finally, everything we find out the risk priority number. And wherever priority number is more means those effects we have to give the recommendations. Just like Pareto, all are not important. So whatever is very crucial, we have to work. Then help us to identify how our process is most likely to failure. So this mostly mostly the process will come in this case. It's not the product. For example, ATM. In the process, what is a failure mode? And then from the failure mode, we are going to know what is the severity and occurrences, and then how we are going to detect. See in three important. The first thing is what is failure mode? So what is going to be the failure mode? And then for that, we have to find out three important things. One is we have to find out the severity, whether it is detectable, because very important, whether some failure mode, whether we can detect it properly, whether it is easily detectable or whether it is very difficult to detect. And the third one is how frequently it is occurring. So these three cases will decide how to find out the risk priority number. Points to process failures that are most difficult to detect. That's what I'm telling you. So three things are there. What is the severity? So we have to, I'm going to rank them. For example, if some failure mode is there, if there is a failure mode, we have to see whether it is less severe or whether, so in a scale of 10, we are going to do. In a scale of 10, so if it is less severe, I will give 1. If it is very severe means I will give 10. If it is moderately severe, I can give 6, 7, something like that. Same way, detection. So that is very important. Any failure mode, many times we will, especially you might have studied in material science, that fatigue type of failure, no, it's without a warning, failure will take place. Without a warning, so that is kind of, we cannot say suddenly failure will take place. So whether we are able to detect the failure mode. If we easily detect it means that's fine. 1. If it is very difficult, means we have to go for 10. Same way, occurrences. Frequently occurring means you give a high ranking, 10. If the frequency is not there, then it's not a problem. So very rarely that type of failure mode is taking place. You have to give 1. So that way, these three, severity, detection, and frequency of occurrence, we have to find out. So this is a failure mode effect analysis. It's a step-by-step approach for identifying all possible failure modes. So that's what failure mode is going to be about. What is the failure mode? The failure mode. And finally, we have to give the recommendation. So in a design, it can be manufacturing. So here we are giving a service industry. That is bank ATM. So which, because you know very well about ATM. So that is the reason we are going to take one example, service. In a service, what are all the possible failure modes we are going to identify? So failure mode means the ways or modes in which something might fail. Failures are, you know what is a failure. So what are any error, defects, especially the ones that are, because here we are not using the word effect. Instead of effect, we are using the word failure mode. The defects, especially the crucial ones which are affecting the customer, can be potential or actual. The effect analysis refers to studying the consequences. That's what, whether it is severe, whether it is detectable, or whether it is frequently occurring or very rarely occurring. So we are studying the consequences. So from the effect, that is what it called effect, failure mode effect analysis. So we are studying the consequences of the failure, whether it is severe or whether it is detectable or whether it is occurring frequently. So failures are prioritized according to how serious their consequences are, how frequently they are occurring, and how easily they can be detected. That's what I was telling. So these three things, the risk priority number, these three things will come, and we are going to prioritize. So for example, if it is very severe means I'm going to give 10 points. If it is less severe means I'm going to give 1 point. So in between, I can have any number. So this way you have to analyze the failure mode. So many examples are available. You can understand. Then only examination I'll give something where you can use your own judgment, because these are based on judgment. You tell it is less severe or it is more severe, and how frequently they are occurring. So whether they are rarely occurring means 1. If it is frequently occurring, that is undesirable. So that means 10. And how easily they can be detected. How easily they can be detected. So easily detectable means 1. If the detection is difficult means that's undesirable. So it is the 10. So the purpose of the FMEA is to take actions to eliminate or reduce failure. That's what any failure we have to reduce. That is very obvious. Starting with the high priority ones. So we are going to find out high priority. That is what I'm doing, risk priority number. So this, I'm telling 1 to 10. This risk priority number is nothing but severity into occurrence into detection. So I tell 1 to 10. So highest priority means the maximum ideally you will get 1000. Because I told 10. So 10 into 10 into 10, 1000 will come. It is less priority means ideally 1 will come, because it is very, very less severe, or it is easily detectable, or the frequency is very, very rarely it is occurring means it is a 1 will come. 1 into 1 into 1, 1 will come. So in between 1 to 1000, we are going to get the risk priority numbers. So this FMEA also documents the current knowledge and actions about the risk. So basically that risk priority number, what is the risk of the failure? So some failure is there. What is the risk associated with it? So that is going to be, we are going to analyze for using continuous, because that is all this TQM is about. The total quality management is about continuous improvement. So we want to make improvement continuously. So FMEA is used during design to prevent failures, because initially we have to do this one. Because once everything is fine means it works initially. So later it is, but of course, even in the later stages also we can be used for controlling before and during the ongoing operations.
So,
pardon me?
So what is the difference between this and physically testing for failures? How they do after a product is created, they put it in the machine to test 1000 speed breakers, etc.
No. Testing is that is different. That is reliability studies. Number of failures and other things. Here it is not like that. Here it is not like that. We are not taking the product. Please understand, we are not taking the product or the service. In the ATM example, we are going to take one failure mode. We are not going to take the product. We have exact product we are not taking. So I will give one example. For example, we want to make because you are mechanical engineers, you know, you want to make a hole of 1 inch hole, 25.4 mm hole there. So the failure mode is there are two, you know very well. I'm just giving an example. So ideally, you make a hole of 25.4 mm. 1 inch hole means it is going to be 25.4. And you know very well, machining process you studied well. When you studied, no, drilling machine is vibrating. Drill bit always oversized hole will come, and all the other things you know because when you make a drill, you will not get exactly the size what we are designing because the component clamping, all these things are there. So there are two failure modes. One is the hole is smaller. Many times that is not possible. Many times no, hole smaller is unless otherwise you use the wrong type of drill bit. Otherwise, smaller hole will not come. Many times oversized hole will come. So two failure modes are there. One is oversized hole, and other thing is so we are not going to see the entire thing. We are taking one failure mode. For example, undersized hole. If it's undersized hole, we are finding whether it is frequently occurring or whether it is severe. If it is undersized hole, it's a problem because the bolt cannot go. Because you know most of the hole making operations, you are going to insert a bolt or rivet. So if it is undersized, you know, the bolt will not go. So that is going to be very severe. If it is oversized holes also, it is going to be a problem. So whether how severe it is and how frequently it is occurring and whether it is detectable, whether it is detectable. So all these things. So we are not testing the product. We are not testing the product. So what we are taking one, we want to identify which failure mode is crucial so that we can act on it. So that's why we will take many failure modes. Any process or product, we will take all the failure modes. And for all the failure modes, I'm going to find out the risk priority number. And the risk priority number, the number is more means high priority we have to give and we have to work on it. So we are not testing the product. It has nothing to do that. That's what they say. It is done before the manufacturing. Initial stages of the design, we have to do this FMEA, so that we can do all the corrections. Everything can be standardized. So that is the idea. So we are not testing the product is entirely different. So that is different. After completing that data, it's different. Here the idea is we are taking a failure. I will go through the example, you understand. Because that is became ATM. We will take 3 or 4 failure modes, and each of them we will analyze whether it is less severe and other things. So that way we are proceeding. And when to use FMEA? So process, as you said, it can be used for process. Many times process, product, service. In our case, we are going to service being used or redesigned after comment. So this is in the design stage. Many times in the design stage, when an existing process, product or service is being applied in a new way. For example, you are trying to change your existing product setup. In that case, you can go for FMEA. Before developing control plans for a new or modified process, when improvement goals are planned, for example. This when to use, just you can skip. So application example, this can be used in manufacturing, design, software. So everywhere we can use. I think many examples are available. So what is a failure mode? So a way in which a component, product, assembly, input, process fail to perform its intended function. So that's what I'm telling you. The failure mode means we want a hole of 1 inch, but we are giving oversized hole. Many times undersized hole is not possible. Oversized hole. So that means that is a failure mode. So failure modes may be the result of upstream operations or may cause downstream operations to be passed. So that's what failure mode. Casting itself, there is a problem because when you are doing a drilling, that is a machining. That machining is the upstream operation is.
So,
Pardon me?
So let's say, for example, one drill has a 1 inch hole it's drilling. Will the change in deviation not be constant for every hole it drills? Let's say it does 1.1. So is that 0.1 inches deviation of oversize not be constant?
No. 1 inch, we have tolerance, ma'am. Many times, the hole size, when the drill, whenever clamping is not proper, when the machine is, for example, one component machine is vibrating, means the oversize will be more. Oversize will be more. So the idea is there is something called tolerance. You know very well. Tolerance is a permissible variation. Anything, you need not manufacture exactly 25.4. So it will be like this 25.4 plus or minus 0.1 plus or minus 0.1. That means it can be 25.5 or it can be 25.3. So there is a range. So if we have to find out how many components they are not within the, because basically we are going to find out the frequency of the failure mode. So that means, for example, if you take some 1,000 holes, if you make some 1,000 holes, how many of them are oversized holes? So we have to find out. So if, for example, if 1,000 only 3 oversized holes are there, means then it is what you call frequency is very less. For example, out of 1,200 holes are oversized, means that means we know there is a what you call something called tolerance within the tolerance. So out of tolerance means oversized 2500 more means that is a failure mode, because you cannot work bolt nut, we cannot do. Sorry with me. Am I
Yes, sir,
answered your
yes.
question?
Yes,
So
sir.
that's what.
So, but then how come
That's
CNC also does the same thing? It tries to keep it within the tolerance stack up.
CNC mission, no, we are programming, because normally, whole oversized wall will come only in a manually drilled machine. CNC machine, unless otherwise the drill bit breaks, no, because CNC everything is controlled, and there is something called resolution of the machine. The machine movement is 10 micron. The machine accurately we can set it to 10 micron means it is 0.01 mm. No, 1 mm is 1000 mm. So 1 mm is 1 mm is 1000 microns. So we can, they will, most of the CNC machines, they will have a resolution of 10 microns. That means 0.01 mm. So we can, up to that we can control. But manually, when we are doing in the milling machine, then when we are doing in a drilling machine, many times oversized hole will come, because operator also influence. But CNC machine, many times,
Okay, sir.
the oversized hole will not be a problem. It will not be oversized
Okay,
hole.
sir. So it's
Everything is
mainly a human error also, all those factors.
yes, yes. When you are doing in a drilling machine, machine will vibrate many times, because CNC machines, their rigidity is very good. They will not vibrate. But they are expensive. That is the problem. CNC machine, if you want to make a hole, I am telling in a very crude way. For example, if you want to make a hole in an ordinary drilling machine, if it is 50 pies, CNC machine, it will be double. It will be 1 rupee. But modern automobile companies, they go for CNC machines, because their profit margin is quite high. So they are all going for CNC machines. So now you try to understand what is the downstream operation, upstream operations. For example, if you take drilling, the upstream operation is casting. So this failure mode is due to upstream. Because there is a problem in casting. Many times it will be a problem in casting or due to operator. In this case, due to operator. So downstream operation means bolt. We are going to insert the bolt. So when the failure mode is occurring, so when there is an oversized wall, the downstream operation, that is a bolt assembly. So this assembly, there will be a failure. So that is what you must understand. So what are the consequences of failure mode? So the failure mode will happen due to the previous operation. Upstream means previous operation. And the failure mode is a problem because for the successive operation, for the successive things that could. So failure mode means things that could go wrong. In the ATM example, I'm going to tell what is going to go wrong. So for example, when the ATM dispenser is not dispensing cash or too much cash, of course, any ATM will not have too much cash. There are some instances ATM will dispense less cash. But being academic, they are going to. So things that could go wrong is, then what are the consequences we are going to study? Because if the ATM is dispensing excessive cash, it is a problem for the bank. If the ATM is dispensing less cash, it is a problem for the customer, and the bank will lose the goodwill also. So whatever things, service industry, the example what we are going to take today, it is going to things that are going to go wrong, that is going to be failure mode. The procedure quickly I'll tell, and then we'll go to the examples, because already it is 10. The assembly a cross-functional team. So first thing is when you want to do FMEA, cross-functional team, everyone you take marketing people, design people, production people, maintenance people. So everybody you take with diverse knowledge about the product. You bring them, either design, manufacturing, quality, testing, all of them. We have to form a team. Identify the scope, because that is very important. Because why, what for? Because in that example, directly I'm going to tell. This way ATM is going to dispense too much cash, too less cash, or why it is happening. All these things we are. So we have to identify what is the scope of FMEA. Then fill in the identifying information at the top of your FMEA form. So this is what example. Directly, if you see the example, no, you will understand. So now the function, first the function is any ATM. You know, ATM is nothing but automatic telling machine. Many people know, they think it is anytime money, but that is not the correct thing. ATM means it is for automatic telling machine, because normally before ATM, no, there will be a teller bank. I don't know, you can ask your father before ATM, no, because I have seen, you can ask your father before ATM. ATM was not there. There will be something called teller. So they will do the ATM job. What is basically, they will receive, they will deposit, they will accept deposit, and they will give.
So is it not similar to a cashier at the bank?
Cashier, they use the word teller. That is the reason I'm telling you. That is cashier, exactly, cashier. Yes, cashier, they used to use the word teller. That's why the name came, automatic telling machine. Automatic ATM, automatic telling. They use the word teller. So now it's not there. Now we are going for digital bank. I think now this present government, no, now internet banking is, they have gone for other level where digital currency, digital banking, so many things now they are planning. Even the budget also, they have said so many things. Now even internet banking is going to be outdated. So that is the way they are proceeding. But before, why I'm telling you, ATM is automatic. There is something will be teller. It's similar to cashier. So now the function of this ATM is to dispense the amount of cash requested by the customer. So I go to the bank, I'm requesting 10,000 rupees. Many times now when I go to ATM, I will request for 10. So what are the three failure modes? So that's what the three does not dispense cash. That is what many ATM, because you might have felt, especially our bank, our nationalized bank, no, that is a problem. Many times it will not dispense cash. It will say temporarily it is suspended. Cash will not come many times. The different reasons are there. That we will see, and what is going to be. Dispenses too much cash. I don't know whether, I don't know, somebody from, it has never happened to me. Too much cash is not there. 10,000 rupees means it 10. For me, no, many times it is 10. Exactly, I'm getting the cash. Even not a single time, lesser cash also is not there. Takes too long to dispense cash. So they have taken some failure mode. Because there are many, because to less cash is also possible. I think they have not taken this, only 3. So this is the function of ATM. So these are the potential failure modes. It is not dispensing the cash, ATM. So that is one failure mode. The second failure mode is it dispenses too much cash, or it is taking too long to dispense the cash. So that is a very irritating. Especially our state bank ATM. Many times it's okay, but sometimes it will take 2 minutes, up to 2 minutes it will take for processing the thing. So these are the 3 failure modes. And please, S means severity, O means occurrence, frequently occurring or less frequently occurring. T means detection. So S means they are giving some numbers. They are given some numbers. Yes, 8 means it is very severe, 10 means maximum severity. 1 means less severe. So out of this, too long to it's a less severe, because you know very well, not dispensing cash is a problem. Long means it's okay. So that's what 3. Severity is at least we are getting the cash. Long time also we are getting. Not dispensing is very severe, So it's in a scale of 10. So if it is very severe means you have to give it 10. If it is less severe means we have to give 1. So 3, they made a comparison. So occurrences. So how frequently they are occurring. So 5 means it's the middle, moderate. So if it 2 means that is it is occurrences not frequent. It is rarely occurring. 2, yes, 2 is the less number. 2, your minimum number is 2. That means very rarely occurring. For example, this discrepancy in cash balancing is occurring rarely. Same way, power interruptions during transaction is acting very, occurrences rarely happening. Whereas in this case, 7 means this one customer somewhat, I'm sorry. Heavy computer network, because you know very well, you know about ATM, no, computer network traffic, we know the problems. In this time, no, we are not able to file the income tax because the server was so I mean, you can ask many people, income tax filing was very difficult. So network traffic. So that means it is frequently, 7 number means it is frequently occurring. Same way deduction also 10. Here it is means 10 means it is not deductible. We will not able to do. So internal jam alert, not deductible. So internal low cash alert. So it will come, low cash alert, it will come, alerts will come. So because you are requesting such that money is not there, that alert is there, so 5 number is there. So like that, we have to give easily detectable means less number. If it is you are not able to detect means we have to give more number. So this number, if you multiply, you will get the risk priority number. That is here you see 8 into 5 into 5. 8 into 5 is 40. 40 into 5 is 200. So that is what RPN, risk priority number. So now to find out the severity, we have to find out the potential effect. That's what very. So this is failure mode. It is not dispensing cash. And there are 3 effects of the failure. There are 3 effects. So this is the failure mode. Now you have just like cost of effect diagram for each effect. So for each failure mode, we are finding what are the effects. Whereas in the cost and effect diagram, only for one effect we are finding the causes. So here for the failure mode, for each failure mode, in this case there are 3 effects. So if it is not dispensing cash, the customer will be very dissatisfied. Next, incorrect entry, because that is you know very well, ATM this will happen. Money will not come, but it will be subtracted in your account. Immediately message will come. 10,000 rupees will not come, but your phone immediately the message will come. 10,000 is deducted, is debited from your account. You know what is credit, what is debit. And for the V8, financial management, you have to go to MBA because we are not offering financial management and marketing management for mechanical students. The only thing is, if you are interested, you have to go to MBA. I think there are some students who go to MBA and they study finance because very important. Financial management and marketing management are very important for mechanical engineers. If the money is not, if it is not dispensing the cash, incorrect entry will come. That is the problem. Cash will not come, but entry it will be debited. Then discrepancy in cash balance, it's almost same. Incorrect entry, cash balancing is not a problem. It's going to be a problem. So these are the effects. So in all the cases, the severity they are given some number 8. Now for the same mode, it is not dispensing the cash. We'll know what are the causes of failure. Now this is the effect. So when it is not dispensing cashes, the customer will be dissatisfied. The second thing is cash balancing. I think this we can omit for understanding purpose. When it is not dispensing cash and the ATM is not dispensing cash, the customer will be dissatisfied. Cash balancing, there is a discrepancy. So these are the effects. Now coming to the causes. So what is going to be the potential cause of failure? One, you know very well, it is now why it is most of the time this is the reason. Cash is not there. Now people are not going to bank. Even myself, very rarely we are going to bank. Sometimes they are sending us a mail or they are sending a letter also. 3 years you are not coming to the bank because in most of the transactions we are doing through internet banking. Most of the money we are doing nowadays we are doing through Google Pay. Now we are.
So can you increase the sharpness of the image? It is slightly strained to read what is written.
Yes, true. When I do, it goes out. That is the problem. Okay, I have to do one thing. The problem is already in the slide mode. Yes, true. What is it? Even
So because a lot of important data is there which you cannot read.
Okay. What I'll do is now the problem is okay. This I no need actually. There is no need to do. No need to have.
So if you click on the image, go to that format. There is a sharpening. Just put it to maximum sharpening.
Okay. Format picture, huh?
Yes, sir.
Format picture.
And then the second option in corrections, the first row is sharpening. Just put it on
correction. Correction.
So the sharpen is the first option over there. Just max it out. So that slider. Below that, the first slider. Yeah. So just push the sharpening even more. So just a slider directly.
This one, no?
No, so below that, you see the sharpening option. Soften and sharpen.
Okay. Sharpening. Okay. Okay. I got it.
So here you can just crank it up. Yes, sir.
Of course, no?
Yes, now it will be better.
Good. Nice. You educated me. Okay. Define current slide. Okay, good. Okay, so now coming back now, this next thing is we are identifying the potential effects of failure. What are going to be the effects of failure? So how, when it is not dispatching cash, I told you the customer will be dissatisfied and discrepancy in cash balancing will be there. Now, next thing is what are the potential causes of failure? So it is not dispensing cash. The major reason will be out of cash. Machine jam. So that is also the second important reason. Second, machine is jamming. So that is also because with the dispenser, automatically something is being done. So the ATM machine is jamming or power failure during the transaction. So these can be these are the three causes. These are the three causes why the cash is not dispensed. So now occurrences. So from the effects, we are finding the severity. So this point is very important. From the effects. So when you do in the examination, when you write, you have to give the effects, 2 or 3 effects. And from the effects, you have to find out whether it is less severe or more severe. From the causes of failure, we have to say what is going to be occurrence. So due to out of cash means out of 10 times now 50% of the time it is due to out of cash. 30% is due to machine jamming, and 20% is due to power failure. Okay. So from the causes, we will find out occurrence. O means occurrences. S means severity. O means occurrences. The third one is current process controls. Current process control. So now for this cause of failure in the ATM machine, what are the process controls available? So this way reduction. But in some cases, this will not be there. Directly, we can say whether it is detectable or not. So you can say something, and then whether it is detectable or not detectable. So this potential failure mode. In this case, they are giving some process control. Many times, it is not dispensing cash. You say whether it is detectable or not detectable. Directly, we can say. So here in this case, internal low cash alert is there. So it is okay. 5 means okay. It is okay. We can detect. Cash alert will come. Cash is not available. Something alert will come. So you know very well the cash will not come. Internal jam is not there. You don't know whether jam is there. So it is not detectable. So internal jam alert may not work. So sometimes that's what basically we have to say whether it is detectable. This failure mode is detectable or not. Instead of going like this. Then we are finding the risk priority number. So just I'm multiplying 8 into 5 into 5, 200. 8 into 3 into 10. 8 into 3 is 24. 24 into 10, 240. So that is why we are finding out the risk priority number. And then we are finding what is recommended action, who is responsible, what is action. And then you make the improvement. Then SOD, once again SOD. That is S means severity, O means occurrence, D means. Then once again RPN we have to find out. Even one more example, I'll give the PPT where you can. Now dispenses too much cash. So the next failure mode is it is dispensing too much cash. The bank will lose money. So that is the effect of the failure is too much cash. Bank will lose because I'm asking for 10,000, 15,000 rupees is coming. Bank problem for bank, and then cash balancing is also again a problem. So they are taking severity. They are given some number. Anyway, here you can use your judgment because you may. But for all these things, so we have to see from customer point of view also. Why it is dispensing too much cash? The currency, cash notes are stuck together. So many times ATM it will not happen because nowadays, I think there's a problem. Now all ATMs, last 5 years, all ATMs they have redesigned. Because initially there was some problem, and now after this demonetization, we are going for new notes. Everywhere 100 rupees. Everywhere there is new notes. Even 100 rupees we are having new notes. 500 rupees everything only from 2016 we are having new notes. So all these things at least working together is not a problem. Denomination in wrong trace. So this may be a reason why too much of cash. So wrong, just the person who is keeping the money, because everywhere no human will come. Even though ATM everything is automatic, somebody is going to place the cash in the tray. 100 rupees tray, 500 rupees tray. Somebody is going to play. Suppose if that person is making a mistake, then naturally too much cash will come. It will never happen because he will be in trouble. The person who was kept will be in trouble. Later they are going to tell them. So in the next thing, what is that is easily detectable or whether it is. So loading procedure. So while loading procedure, you have a procedure. procedure, 2% visual inspection, because many times one person will load, the next person, that is what they're doing. The next person will come and do the inspections. So this way we can detect to this type of thing. Same way, the loading procedure, the detection rate we can. But here you don't worry much about it. The idea is too much cache, whether it is detectable or not detectable. Here also we are finding the risk priority number. Now taking too long to discuss it. So many times ATM this one. So what will be the consequence, effect of the failure? The customer will be annoyed. So when it is taking, normally now we were so busy nowadays. Now many times now people are going at 10 o'clock, 10:30 for ATM, because people now less ATMs are, less number of ATMs are there. So people know. So if it is taking too much time now, customer will be annoyed. So that is going to be the effect of failure, because severity is not there compared to the other two failure mode. No, even if it is takes time, at least if it is dispensing cash means that's why the severity number is very less in this case. This case very less. Now, what is the potential cause of failure? So why this too much time is taking? And there can be two reasons for that. Two causes. One is heavy computer network traffic or power interruption. These two reasons can be there. So of course, network traffic is always creating. You know very well now India so much computerization is there, because because I studied my BTech course before 1989. You know very well now, after 1989 only so much computerization has taken place. I studied 84, 88. At the time, because that computerization word is new to me. But you guys know, you have never seen life without computers. For me, no, I have seen the word, because college at the time, no, at the time only computerized railway reservation. First time, no, computerized railway reservation. Then computerization. So when now almost India, no, like any other country, we have so everything is there. Whatever the internet, so many things. So many advances are there. So that is the reason that heavy computer network traffic is there. So that is the reason it is taking too much time. Because always it lands. That is the reason many people, they go in the night, because network traffic will not be there. After 10:30, if you go to ATM, no, because it is 24 hours, you can go, no, then network traffic will not be there. Lesser time we can do. Power interruption, of course, India, that is a problem, power interruption. So occurrences, you see, so this power interruption is they are giving less, very rare only power ATM, because they are battery operated. I think alternate thing is there. Power, if power goes also, I think battery is there. So here, heavy computer network traffic is a problem. Sometimes it is a problem. Here detection, too long time. Detection we will not. This failure mode, we don't know. We can not very difficult to detect too much time. What is the thing? That's why they given that term. So the risk priority number we are calculating. So here, very quickly I'll tell for how for each failure mode identify all the. So 1 minute in there. Ten minutes sketch pantangla. So for each failure mode, identify all the consequences on the system, related system. So they are potential effects. That's what I was expecting. So when you want to first identify the failure mode, the next thing is what are the effects or consequences? What are the effects? So what does the customer experience because of the failure? That's what in the ATM example. What happens when this failure occurs? All these things, and determine how serious each effect is. So this is the severity rating. So yes means severity rating, where severity is usually rated on a scale from 1 to 10. That's what in the previous ATM example I'm showing 7, 8, something like that. So if it is less severe means 1. If it is more severe means 10. So 1 is insignificant. So we are not worried. 1 means 10 means catastrophic. It's a problem. So if a failure mode has more than one effect, right on the 1 minute. So if the failure mode has more than one effect, that's what in the example we have given more effects are there. For each of them, we have to find out what is going to be the RPN number. For each failure, we determine all the potential root causes. So that's what the next step. First step, what is the consequence of the effect? Then we find out what is severity. Next, you find out what are all the potential causes, just like cause and effect. So this is for finding out whether it is occurring frequently. This is for occurrence rating. So this causes is for occurrence rating. So for each cause, you determine the occurrence rating. So this rating estimates the probability of failure occurring for that reason during the lifetime. So occurrence is usually rated on a scale of 1 to 10. 1 is extremely unlikely, very rarely. 1 means rarely or unlikely. 10 means inevitable. So frequently occurring. It is inevitable, that's unavoidable, or it can be frequently occurring. So on the inevitable, list the occurrence again. So all there is a number. In the previous example, I have shown a number for O everywhere. For each cause, directly identify the process controls. So these are the test procedures or mechanisms. That's what I think even Avita was asking. So what are going to be the procedures test for each failure mode? What is the process? For example, in a drilling a hole means we are going to do the inspection. So then that you may have in the place to keep the failures from reaching the customer. So these controls might prevent. So for in the ATM example, cache alert is there, cache alert. So all these things to identify. Then for each control, determine the detection rating, whether it is easily detectable or so many times that is very important. Many times, no, sometimes of failure modes we will not be able to detect. So here, no, because computerization they are able to do. So if the cache is not coming, alerts can be given. Now you know that is an advantage of computers. Whenever there is a, we can give some alerts so that we can detect something is wrong. We can detect at least we are happy. We know, for example, there is a cache is not available. If that alert is coming, at least that's okay. That failure mode, it's okay. We know it's a cache. The next day we can come. So if cache without any alert, if cache is not coming, it is a detection. The next is calculating the risk priority number, RPN. So S into O into D. So severity we are giving a number, occurrences O we are giving a number, detection we are giving a number. You multiply them, you get the RPN, risk priority number. The criticality by multiplying severity by occurrence. Okay, just don't worry. You say S into O into D. So S is severity, O is occurrence, D means detection. So this number can be as high as 100 because S can be 10, maximum S can be 10, O can be 10, D can be 10. So that means 10 into 10 into 10. So the maximum can be 1000. The minimum is 1 because severity I can give 1, O I can give 1, detection I can give 1. So in that case, it will be 1. Then identify the recommender. That's very important. Once you know all the failure modes, within the failure mode for each cause, for each effect, for each control, all these things, everything you find out the risk priority. Then you have to recommend what should we do. So I think maybe Monday's class, I will give some. We have some examples what recommendation we have to give all these things. So these actions may be design or process changes to low severity. That's what. So when you do the recommended action, the severity that's what the right side ATM example right side after modification what is the severity, what is the occurrence. The occurrence will come down, the severity rating will come down, or we can give additional controls to improve the detection. So that is the idea. The idea of giving the recommended action is we want to lessen the severity, we want to reduce the number of occurrences, and we want to improve the detection. So for that, we have to add controls like cache alerts and other things. As actions are completed, note results and data. So with this, I will stop for this class. So I will stop the recording.